So in the last video in this, we're going to look at pulmonary volumes and capacities. What this is we're able to determine our lung capacity and volume using a technique called spirometry. Spirometry is essentially just a special device that you breathe in that can record these volumes. So what you can ultimately create is a tracing similar to this, and we'll walk our way through all of these. So if you start out, so the beginning is the first definition we need to know is residual volume. This is simply the volume of gas remaining in the lungs after maximum expiration. So to get your residual volume, what you would do is blow out all the air in your lungs until you couldn't blow any more, and then you would hold your breath. There would still be a small amount of air left in your lungs that would constitute the residual volume, and it actually is quite large. About a liter, a little bit more than a liter is the residual volume. So then if you were to take in an amount of air inhaled just at a normal level, right? So not a big breath, not a heavy breath, just a nice relaxed value. I'll say this is somewhat difficult to do in the lab because it's very difficult to get someone to breathe nice and quietly while breathing. But each breath that you breathe in would be the tidal volume. We'll see the average tidal volume here is about 500 milliliters of air per breath. So then if you move from taking a nice quiet breath to breathing in all the air in a maximal effort breath that you can breathe in, what that would do would be called an inspiratory reserve volume. This is, again, that reserve of breath that you can take in as much as possible. This usually is pretty large. So this is about 3 liters of inspiratory reserve volume. And then if you exhaled with maximum effort, the difference between the expiratory volume and your normal tidal volume then would be what's considered the expiratory reserve volume, or that volume of air that you can blow out in a forced all-out maximal expiration. And again, as we've talked about, what's left is residual volume. The expiratory reserve volume is about 1.2 mils or 1.2 liters. You don't necessarily need to know that. Our residual volume, though, we'll say is about 1 liter. So then if we then go to vital capacity. Vital capacity is the maximum amount of air that can be expired after maximal inspiration. Right? So it is ultimately the addition of the inspiratory reserve volume, tidal volume, and expiratory reserve volume all fill into the vital capacity. So this is going to be about 4.7 liters in the vital capacity. Again, addition of expiratory, tidal, and inspiratory reserve volumes. Inspiratory capacity, as you might guess, is the maximum amount of air that can be followed with a normal expiration. So starting at a tidal volume, here would be this breath plus a maximal inspiratory capacity. So ultimately what that will give us is this is equal to our tidal volume plus our inspiratory reserve volume gives us our inspiratory capacity. For most people, that's about 3.5 liters. Our functional residual capacity is the amount of air remaining in the lungs following a normal expiration. So you can see that here, and we can calculate that by adding our residual volume and our expiratory reserve volume. So after a normal breath, what is our volume left in the lungs? That's our functional residual capacity, about 2.5 liters. And then last but not least is the total lung capacity. This is maximal inspiration plus maximal expiration plus residual volume, right? So we can add in residual volume or functional residual capacity and inspiratory capacity to give us this. And for most people, this is about 6 liters. These values are all in a chart in the next graph, which we won't go out. But again, that just kind of sums them up and gives you an idea of how these all work. And again, since a lot of this is unfamiliar, as a student, you just kind of have to memorize some of these processes. But you should definitely know each of these definitions and where they can be found on this curve and what they measure. Okay, so if we then look at how we can lump these two together, so if we think about comparing them, lung capacities that represent functional groups of lung volume. The first is the vital capacity. Again, as we talked about, the vital capacity is inspiratory reserve volume plus tidal volume plus expiratory reserve volume. We can also have inspiratory capacity, which is tidal volume plus inspiratory reserve volume. And we can have the functional residual capacity, which is expiratory reserve volume plus residual. Again, this is just showing you another way that we looked at at those figures, and the last half of those definitions were how we could calculate these. Some of these then are going to change during exercise. So if we look at what's going to change, first thing that's going to change is our tidal volume is going to increase greatly. Right? We're going to increase the volume of air that we take in per breath, which makes sense, right? And you can experience that if you go out jogging. We see no decrease or no change in residual volume of the lungs, so no ability just to hold air after maximal inspiration. However, we do get a decreased inspirational reserve capacity, or inspiratory reserve volume, and expiratory reserve volume. So why is that? That's because our tidal volume is cutting into our inspiratory and expiratory reserve volumes. Right? So if tidal volume is greater, then our reserve capacity to inspire and expire air is smaller because so much of that is being taken up by the tidal volume. And then, of course, total lung capacity. That won't change, just tidal volume. So if we take a look at changes in minute ventilation, this is gas moved per minute, which is tidal volume. So we can say this is V dot, which is tidal volume times frequency. Some general numbers. At rest, we breathe about half a liter per minute at about 12 breaths per minute, which gives us a minute ventilation of about 6 liters per minute. Right? All we did was multiply 12 times 0.5, gives us 6 liters. However, during exercise, we're going to increase our tidal volume, as we just saw in that last slide, plus we're going to breathe a lot faster. So as you can imagine, 4 liters per minute of a pretty intense exercise, we can then breathe more frequent, and therefore we not only increase tidal volume and frequency, but these result in a much larger minute ventilation or volume of air that is getting getting into the lungs to deliver oxygen for metabolism. So if we look at why do these lung capacities matter, so again, we can use this spirometer that measures lung volumes. COPD is the most obvious thing to talk about when we look at lung volumes, but we can use these because COPD has chronic obstructive pulmonary disease, which causes an increased resistance in flow and ultimately causes a decrease in expiratory capacity. They get an increase in residual capacity, a decrease in vital capacity, and a decreased ratio of forced expired volume to vital capacity. In other words, they aren't able to expire air nearly as well, therefore they get a lot more have a much more difficult time breathing and have to work much harder in order to do that. So we can look at this. One of the clinical things that we'll use is called FEV or FEV1. FEV1 is essentially the forced expiratory volume of air in 1 second. So what you do to measure this is you do a max inhalation followed by a forced max exhale as fast as you possibly can. right? So in a healthy person, they should be able to have an FEV1 divided by our vital capacity, or the maximum volume that can be expired after inspiration, of greater than 80%. If they don't, they have a COPD. You can't see this. This is less than 80% here. So in summary, to finish up the chapter, what we see is that pulmonary ventilation refers to the amount of gas moved into and out of the lungs. So you'll hear me, I'll use pulmonary ventilation a lot. That's the same thing as just V, right, the volume. The amount of gas moved per minute is a product of tidal volume multiplied by breathing frequency, and we can measure these using spirometry. Right? Vital capacity is the maximal amount of gas that can be expired after a maximal inspiration, and last but not least, our residual volume is what's left in the lungs. So hopefully some of these definitions, which may just take some time, you'll have to kind of work on discussing them, and I'll have that as a assignment here soon. Have you go in and actually walk through the drawing as a discussion so that you can get some practice as one of your assignments. But that ends it for the structure and function. Tomorrow we'll actually get into gas exchange.